So today we're talking about amines, and then at the end of the lecture I'm going to give you some enrichment problems to do that will go over what we talked about last time with the benzene, substituted benzenes, and then also have some enrichment problems on amines. So it's kind of a shortened lecture on amines and then a enrichment time. So let's talk about amines. Amines are molecules that contain a nitrogen, okay? And that nitrogen can exist as an NH2, it can exist as an NH, or it can exist as an N. And I'll show you what I mean by that in examples in the next slides, okay? But at minimum, it's going to be an NH2. Then depending on what it's bonded to, it could also be an NH or just an N. I'll show you examples on the next slide. In other words, nitrogen's always got to have 3 bonds. So if it's just connected to a carbon, it'd be NH2. If it were connected to 2 carbons, it'd be NH, and if it were connected to 3 carbons, it would just be N, right? That nitrogen atom's always got to have 3 bonds. So let's look at examples. We call an amine where the nitrogen is attached to just 1 carbon. We call that a primary amine. And we're going to use this naming when we talk about alcohols too. So it'll work exactly the same way next week when we talk about alcohols. So a nitrogen that's connected to just 1 carbon atom, we call that a primary. We put 1 with a little degree sign. Okay, notice the nitrogen atom has 3 bonds, 1, 2, 3, and then it's got that lone pair as well. A secondary amine is attached to 2 carbons, right? So you notice this this nitrogen's attached to that carbon and that carbon, but nitrogen has got to have 3 bonds total, right? So just like carbon's always got to have 4, right? This nitrogen's always going to have 3. So if the nitrogen's attached to 2 carbons, then that means that there's another hydrogen on there. And then that lone pair of electrons. We call that a secondary amine, right? It's attached to 2 carbons. And then here would be an example of a tertiary amine, right? It's attached to 3 carbons. So there are no hydrogens, all 3 carbons. In a secondary amine, there's 1 hydrogen and 2 carbons, and in the primary amine, there are 2 hydrogens and it's attached to 1 carbon. We again use 1 with the degree, 2 with the degree, 3 with the degree to differentiate because that's a shorter, it's way shorter to write 3 degree than to write out tertiary. Do you see the difference between primary, secondary, and tertiary? Okay, so carbon, just like carbon's always got to have 4 bonds, the nitrogen's always going to have 3, okay, because that nitrogen's got a lone pair of electrons. So that's how we differentiate there. So let's take a second and classify these as primary, secondary, or tertiary. What would this one be? Now, I didn't draw the lone pair, but you can tell just by looking at it. Primary, secondary, or tertiary? That'd be tertiary, right? It's attached to 1, 2, 3 carbons. What about this one? That'd be secondary, right? Because that's a carbon and that's a carbon. And then what would this one be? That's also secondary, right? Because that's a carbon and that's a carbon. Good. Okay, so what are some of the properties of amines? What are some of their physical properties? Well, that NH is capable of hydrogen bonding, right? Because remember, we said anytime a molecule contains NH, FH, which is rare, or OH, right? NH and OH are the 2 most common ones we'll encounter in organic chem. That's a very polar bond. It's a special type of dipole-dipole, which we call hydrogen bonding. So that means that is hydrogen bonding a strong IMF or a weak IMF? Strong, right? Hydrogen bonding is a really strong intermolecular force. So that means that these molecules are going to have a lot higher boiling points than just, say, a straight-up alkane, right? An alkane, let's say butane, versus a butane with an amino group on it is going to have a whole lot higher boiling point, right? Because one's going to have hydrogen bonding and one's just going to have London forces. In terms of their solubility, amines are soluble in water because water is polar, right? Water is capable of hydrogen bonding. The amine is capable of hydrogen bonding. So those IMFs are compatible with each other. And they're soluble so long as the chain is 6 or less. 6 or less. That's the magic number. Around 6, 7-ish, solubility goes. And why would that be? Because if we've got this big long chain, now we've got a part of the molecule that's just too non-polar to be compatible with a polar solvent. Right? So if we had if we had, let's say, 1, 2, 3, 4, 5 versus right? IMFs here would be London only, right? This is nonpolar, whereas this is London and hydrogen bonding, right? This part right here is capable of the hydrogen bonding. And then the rest of this thing would be capable of London. And then when we get these big long chains, right? Right, that is capable of hydrogen bonding. That could hydrogen bond with the water, but this piece is now, there's too much nonpolar to offset that polar, right? So this is nonpolar. So this would be insoluble. The nonpolar section is too big, right? Whereas if we had this, right, this would be soluble. Okay, do you see why? Because the hydrogen bonding can offset the short little piece. Okay, so this is the same rule we're going to follow with alcohols. When we talk about alcohols next week, alcohols are going to be soluble in water as well for the same reason, as long as the chain is 6 or fewer. Once you get above 6, 7, 8, 9, 10, that the solubility just drops out. Okay. So, erase my screen here. I've got a question. Here are 3 structures. I guess I can put my screen back down now. Okay, here are 3 structures: methylamine, dimethylamine, and trimethylamine, right? Primary, secondary, tertiary. And so my question is, who's going to have the highest boiling point? Highest boiling point. So let's think about boiling point. Remember, if the boiling point is high, does it have strong IMFs or weak IMFs? Strong IMFs. So all of these have what IMF? They all have London forces, and they all have not dipole. The NH is capable of hydrogen bonding, right? So they're all going to have, all the amines are going to have hydrogen bonding. All the amines are going to have London forces, right? So who's going to have the strongest net IMFs? The biggest one, right? So this one would have the highest boiling point. And then who will be the most soluble? The smallest one would be the most soluble in water. Good. Right? Because all 3 of them are going to be soluble. Don't get me wrong. All 3 of these will dissolve, and they'll dissolve great. Right? You're not going to have a problem getting any one of these to dissolve in water because the chains are all less than 6. But the smaller the chain, the weaker the London forces are. Right? So pick the smallest one there. Okay, here are 2 molecules. This figure's from your textbook. Why is this molecule more soluble than this one?
Because the chain shorter.
Right, chain length. This one is a 1, 2, 3, 4 versus a 1, 2, 3, 4, 5, 6, 7, right? We wouldn't really expect this to dissolve very well at all. We'd expect this to dissolve great. Do we see the physical properties part, how that works? Okay, let's talk about how we name some really, really, really simple amines. So no substituents here. We're just looking at basic amines. So we take the alkane, butane, propane, heptane, octane, whatever, and then we put amine at the end. And if we've got some methyl groups, we'll state how many of them we have. So here was the one we just did a minute ago. Right? This is just an NH2 on a CH3. So that's just methylamine. That one's super easy, right? Nothing fancy there. This is an amine, and it's got a methyl group here and a methyl group here. So we would just call that dimethylamine. This is an amine with a methyl group here, methyl group here, methyl group here. So we're calling this trimethylamine. Okay? These are all super, super, super simple. Right? So we're just looking at basically the simplest amine you can possibly have, right? Methylamine is the simplest amine you can get. It doesn't get any simpler than methylamine, right? Unless you have ammonia, which is just ammonia. It's not, it's not an organic molecule in terms of there's no carbons. And then the next simplest amine you could have would be dimethylamine. And then the next simplest amine you could have would be trimethylamine, right? Those are the smallest it's going to get. Well, let's look at some amines that are a little bit bigger. So we're going to treat the NH2 group just like any other substituent, okay? And then we're going to change the suffix to amine, but we also need to state where that NH2 is located, okay? So for instance, this would be 3-heptanamine. Now again, remember when we talked about splitting up the suffix a couple lectures ago when we were talking about alkenes and alkynes. Remember I said you could split it up. You could also name this heptan 3-amine, right? If you want to split it up, put the number in the middle of the word, that would work too. Okay. But why is the 3 necessary? Because this NH2 could be anywhere, right? It could be here, it could be here, it could be here, right? So the 3 is telling me, okay, it's a 7-carbon chain with an NH2 on carbon 3. Now, if there's another substituent, the amine takes precedence over whatever that other substituent is. If it's a methyl group or a chlorine atom or whatever, right? The amine is going to rank higher than that methyl group. That's why we're numbering from this side instead of this side, because you want to give the lower number to the amine. So 5-methyl heptan 3-amine, right? That's what it looks like if you split it up. Your book keeps it together, keeps the word together, 5-methyl 3-heptanamine. So I'll accept either, and I'm pretty sure your online homework accepts both as well. But I always like to show both, just because depending on the book you're looking at, you might see one versus the other, and they're both acceptable. Now it works the same in a ring too, right? So this will be cyclohexanamine. Why is the 1 not needed in a ring? It would definitely be needed in a linear, right? If they were on carbon 1, you'd have to put 1-heptanamine. Why don't you have to put the 1 if there's no other substituent? That's by definition number 1, right? And then if there's another substituent like a methyl group, right? This one pulls rank over this one. Okay, so that would be 2-methyl cyclohexanamine. Make sense? All right. So these are, again, these are still pretty easy. These aren't ones that are too difficult. So why don't you try, and I'll pause the video, 3-chloro-2-heptanamine and 2,2-dibromocyclopentanamine. I don't know why I keep lowering the screen. I'm just going to have to raise it back up again. Just not planning ahead. All right, let's go over this one. So heptan would be how many carbons in the chain? 1, 2, 3, 4, 5, 6, 7. 3-chloro, 1, 2, 3-chloro, 2-heptanamine. Right? Now you could have also written that as 3-chloroheptan 2-amine if you wanted to put the 2 in the middle of the word. Again, your book keeps things together, but some books you'll see it, the 2 shoved in front of the functional group. Okay, this is a cyclopentanamine, so how many carbons are in the ring? 5-carbon ring. And 2,2-dibromo. And then NH2. We good on that one? Okay. Where'd my clicker go? There it is. Okay, now let's talk about amines that are parts of longer chains. So they're a little more involved in their structure and they're a little more involved in their naming. So the first thing we're going to do is we're going to figure out the longest chain that's attached to the N atom. So for instance, when you're talking about dimethylamine, It's a CH3 and a CH3 on both sides. Who cares? All right, well, what if you've got a molecule where you've got a long chain on one side and a short chain on the other? That's what we're talking about here, okay? You need to figure out the longest chain that's attached to the nitrogen atom. And you're going to call it the parent. So it's the one that's suffix is going to become amine, okay? And I'll show you some examples of this. And then we're going to number that parent chain to show the position of where the nitrogen atom is. Okay, plus any other substituents if there's a chlorine or whatever. And then all the ones we're going to do are all going to be alkyl substituents. Okay, so I'm not going to make you worry about ones where, for instance, there's an NH2 and an alcohol. That's two functional groups, and this is just elementary organic. We're not going to worry about multiple functional groups. So all the ones we're looking at are just going to be alkyl substituents. And then they're going to get the prefix N. And so then we're going to just treat it like any other substituent. I know that sounds really funky, but when you see the example, I think it'll make more sense. So do you want me to pause it so you can jot this down, or?
No, I don't.
Okay. So let's do this one together. So we've got 1, 2, 3, 4 versus 1, right? So we're looking at who's attached to the nitrogen atom, right? This is obviously the longer side than this side is, right? So this is going to be considered the parent chain, okay? So that's a butane. So it's going to be called a butanamine, right? But this CH3 isn't attached to the chain over here, is it? It's attached to the nitrogen atom, okay? So it's called an N-methyl group, because it's a methyl group and it's not part of the chain. It's not like it's a substituent over here. If it were, you know, sticking up right here, we just call it methyl because it's part of the parent chain. But that methyl group isn't part of the parent. It's part of the nitrogen. It's a substituent on the nitrogen, right? So it's an N-methyl. And this whole piece is on carbon number 1, right? So it's 1-butanamine, but we got to stick something in front of that. It's N-methyl 1-butanamine. Does that make sense? So in other words, again, you can think of this as a substituent on a substituent. Because if it were just butanamine, that would be NH with 2 hydrogens, right? 1-butanamine would be NH2 right here. But one of those hydrogens has been pulled off and a methyl group's been put in its place. So we're basically treating this like a substituent on a functional group. So that's why it's N-methyl and then 1-butanamine. Because again, if this were just a regular old hydrogen, we'd just call it 1-butanamine, right? But because that hydrogen's been replaced with a CH3, it needs to be called N-methyl 1-butanamine. Does that make sense? So you need to just figure out the longest chain. And then again, if it's just a regular old NH2, you would call it hexanamine or whatever, right? But if there's a substituent on your functional group, that's where this comes from. So let's figure out this one. We need to first identify the longest chain. So we've got 1, 2, 1, and 1, 2, 3. So the longest chain is the 3-carbon chain, right? So that's the longest chain. And so it's going to be propyl, which is going to get then changed to propanamine, right? But this is not a regular old NH2, right? If this were NH2, we'd just call it what? 1-propanamine. We're done, right? But this isn't a regular old NH2. This N has a substituent here and a substituent here, right? It's got an ethyl group and a methyl group attached to the nitrogen. So how's that going to get incorporated into the name? Well, we'll need to say N-ethyl, N-methyl, 1-propanamine. Put them in alphabetical order. E before M. In terms of primary, secondary, or tertiary, what kind of nitrogen, and what kind of amine is that? That'd be tertiary, right? Do you see where that name came from? In other words, we're pretending that this amine has 2 substituents on it. N-ethyl, N-methyl, 1-propanamine. Make sense? All right, I'll give you a second to think about this. Here's one. What's its IUPAC name? All right, let's go over this one. So we have to identify the longest chain, 3 versus 2, right? So that's going to be propyl. And then if this were just a regular NH2, we'd call it 1-propanamine, but it's not. It's a amine that's got a substituent. That's how we're going to treat it, right? So that's an ethyl group. So the name would be what? N-ethyl, 1-propanamine. Good. Make sense? Makes sense. Okay, why don't you try this one? I'll pause the video. Draw the skeleton structure for N-ethyl, N-methyl, 1-butanamine. All right, let's go over the answer here. So this is a 4-carbon chain, right? Because it's butanamine. So 1, 2, 3, 4. Now here's the problem that a lot of students run into. This needs to be 4 carbons long before you start putting any substituents on, right? If we put an N right here, that's a 1, 2, 3 carbon chain, right? So make sure that your chain has the correct number of carbons. Because this is a really common mistake I see students make. They'll start counting out 1, 2, 3, 4, and then they'll start sticking stuff on the end, and they accidentally chop off one of their carbons. So 1-butanamine would be this, right? But that's not what we want. We want N-ethyl, N-methyl. So what's that going to look like? Ethyl will be 1, 2, right? And methyl would be that. Right? That's a 2-carbon chain. There's the ethyl part. That's a 1-carbon chain. That's that. And then there's the butanamine part. Do we agree? And then the last thing I want to talk about before I turn you loose on some enrichment problems would be aromatic amines, which we talked about earlier this week, right? Anilines. So a benzene with an NH2 is called aniline, right? What if we took one of those H's off and replaced it with a methyl group? We could do that, right? This would be N-methyl aniline. Does this make sense? Because if this were just regular NH2, we'd call it just aniline, right? But we've yanked off one of those hydrogens and put a methyl group in its place, so it's N-methyl aniline. Does that make sense? Okay, so now what we're going to do, people here on campus are going to get this handout. I'm going to pause the recording while they work on it. We're going to have some review problems from earlier in the week. Nomenclature of substituted benzenes. So this is a review of what we did in our last lectures. So I recommend you pause the recording, try these for yourself. Now notice it says if more than one name exists, list them all. So try these. Online students, you can go to the course website and just download this file. That works too. If you're not watching this with access to the course website, then you can just pause the recording and try it for yourself, and then resume when you're ready. And then draw these amines and complete these 2 reactions. And by complete, I mean list any sort of catalyst that you would need, and also name the product. So I'm going to now pause the recording, let people on campus try it, and then we'll go over it. Okay, we've all had some time to try these problems, so now we're going to go over them. And again, the instructions say that if more than one name exists, we want to list them all. This is good practice for you, see the homework. because I know that there are problems on the homework that ask you to list all the possible names if there is more than one. So in number 1, do we have more than one name? Yes, I came up with 3. So we could call this, what's a benzene with 2 methyl groups called? A xylene, right. And these 2 are side by side. So how can we represent that? We could call it O-xylene, right? What else could we call it?
1,2-dimethyl.
Right? 1,2-dimethyl benzene. We could do one other thing.
I put O-dimethyl.
Yep, that works too. Yep. There are 3 names that would work. O-xylene, 1,2-dimethylbenzene, and O-dimethylbenzene. Most common mistakes, forgetting the di, right? Forgetting the di is a very common mistake I see. Good. So number 2 is very similar to number 1. What's going to be the only difference? The numbers, right? So when they're across from each other, what is that called? That's para, right? So you could call this P-xylene. You could call it, what is it when they're across from each other? What number would that be? 1,4-dimethylbenzene. And then you could also call it P-dimethylbenzene. Good. Any questions on 1 or 2? They're the same, right? If you understand 1, I think you probably understand 2 pretty well. And then in number 3, I came up with 3 names as well. What is a benzene with an OH group called? Phenol?
Oh, yeah.
Phenol, right? So this is called a phenol. So what's one way you could name that? 3-chlorophenol works. What else works?
3-chloro-hydroxybenzene.
Right? 3-chloro. Now I'm not sure, I can't remember, I haven't been on the homework lately. It might make you put that 1 in there. I can't remember if it does. So you wouldn't be marked wrong if you stuck it in there and you didn't need it. But I can't remember if the homework gets picky about that or not. So just FYI, you might, when you're doing that in the homework, if that marks that wrong, just try putting the 1 in there and see if it makes it happy. There's another one that would work. These are 1, 2, 3 carbons away. So what's another way we could write that? When they're 3 carbons away, M, right, meta. So you could also call this M-chlorophenol as well. Right? Are we good on number 3? Now, like I said, your homework might get picky about having that 1 there or not. I can't remember. But if it counted you wrong for that, just go back and stick that 1 in there, and they probably should be happy at that point. All right, let's move on. Okay. So there's only 1 name for number 4 because we don't know any rules for a bromine substituent, right?
1,3,5-tribromobenzene.
Yep, that's the only name. 1,3,5-tribromobenzene. Because the O, M, and P don't apply to 3 substituents. It only applies to 2 substituents. So yep, that's the only name that works. What about 5?
3-bromo.
3-bromoaniline works, yep. What else would work?
Wait, you can't use this on benzene.
Mhm.
They mean to learn direct.
Mhm. You could name this is carbon 1, 2, 3, right? So you could name this 3-bromo 1 aminobenzene. That would work. And there's one more. When they're not next door and not across, what letter could we use to replace the 3 in the aniline? Right, so you could also call this M-bromo aniline. 3 names work there. All right, what's the name for number 6? There's only one name.
Numbers. Oh, I don't have that numbers. I thought it was on the other.
Now look at this. Does this NH2 have any substituents on it? It's just a straight up amine, right? It's not a substituted amine. So this one just falls into our simple category, right? This would just be 2, what's a 4-carbon chain called? Butanamine. Right, that's just 2-butanamine. Because that's a straight up NH2, right? There are no, we haven't replaced any of those hydrogens with alkyl groups or anything. So that's just 2-butanamine. And then if you wanted to split it up, right, you could call it butan 2-amine, if that's the way you like to write it. But your book keeps it together, so I tend to go with what your book uses. But some textbooks would split them up like that. Do you see why you don't need to call any N-ethyl or anything like that? That's just a regular old NH2, right? None of those hydrogens have been replaced with like an alkyl group. Here's 7 and 8. All right, so let's name 7. Now this is not a regular old NH2, right? This was just a regular NH2, no substituents, we're not replacing any of the hydrogens with alkyl groups. But in this one, we have, right? So we need to use our N rules, right? N, bromo, or whatever. So what is the longest chain? 1, 2, 3, 4, 5, right? And so this is a what? Methyl. And so is that one, right? So what would the name of this be? Close. N-dimethyl. You forgot the 1. 1-pentanamine. Right? You need that 1. Because this whole thing is sitting on carbon number 1 of the chain. Make sense? Number 8. This is our functional group, right? The N right here is our functional group. Is it a regular old amine, NH2? No, it's a modified amine, right? So again, we need to find our longest chain, which is how many carbons long? 4, right? 1, 2, 3, 4. And then what kind of group do we have? These two are the same. They're both what? Ethyl, right? So what will this be?
N-diethyl.
Right. Good. N-diethyl 1-butanamine. Common mistakes, not putting 2 N's That's a very common mistake. A lot of students will write N diethyl instead of NN diethyl, right? Because the reader needs to know that those ethyl groups are both on the nitrogen atom. So a lot of common mistakes are involved either forgetting to put one of the N's or forgetting the di, right? They'll put NN ethyl instead of NN diethyl. Or they'll put N diethyl. Those are the two most common mistakes. Any questions on 7 or 8? Very good on those. All right. And then spell check doesn't like that word. Draw these amines. Okay, what would regular old aniline look like? Regular old aniline would be that, right? That's aniline. So what would N-ethyl aniline look like? All right, so one of those hydrogens has been replaced with an ethyl group, right? So you can draw that however you want it. Just remember, you do need to have that H there, okay? Because if you omit it, now we've broken some rules. We've taken an amine and we've just replaced one of those hydrogens with an ethyl group. So that hydrogen is necessary, okay? You do need to show it. Because otherwise you'll look at that and go, something's wrong, something's missing. Because it should be an NH2 and we've replaced one of those hydrogens with an ethyl group. All right, let's do number 10. Propanamine, pro would be how many carbons long? 3, 1, 2, 3. And then on carbon number 1, we've got a nitrogen atom. And it's not just a amino group, right? It's not just NH2, because that would be just propanamine, like one propanamine, right? We've replaced those hydrogens with what? With methyl groups, right? Questions on 9 or 10? Okay. And then let's complete these reactions. What kind of reaction is this? Mm-hmm.
It is halogenation.
This is halogenation, right? What catalyst do I need? Fe, right? You could have also written FeCl3, that'd work too. Are you going to get this? See that a lot. Are you going to get that? No, we're not treating this like an alkene reaction, right? Because the benzene, it stays intact. What are you going to get? Well, not 2 chloros, because if you had 2 chloros, this carbon would have 1, 2, 3, 4, 5 bonds, right? So you're not going to get 2 chloros. You're going to get just 1 chloro, right? So the product here is chlorobenzene. And then there's another product. Remember, this hydrogen got yanked off. Where did it go?
Well, then you get H2.
Not H2, HCl, right? Because if we think of this as Cl, Cl,
Oh, there's the other one. Gotcha.
right? There are 2 chlorines there. So 1 chlorine goes onto the benzene ring, the other chlorine gets together with the hydrogen that we kicked out. So that's our other product. Okay, what type is number 12? That's nitration. What catalyst do we need?
H and E.
H plus, right? We need a strong catalyst, a strong acid. And so what are we going to get? We're not putting an amino group on here. We're putting a, what kind of group? NO2 is called a nitro group. Right, that's nitrobenzene. And then your other product is water, right? Good. Now I think on the, didn't I ask you a question about drawing a,
On the other one,
yeah, on the other one. Let's just go ahead and do that one just for fun. Okay. So let's just do that. So there was a bonus question on here that wasn't on the, I just asked my on-campus students, just for fun. What was it? Draw a name.
And 5-member ring with an NH2 group and a CO.
5-member ring, NH2 and a Cl. That's right? Okay. So if we were doing this, there's our 5-membered ring. There's NH2. There are only 2 choices, really, for name, right? Because you could have the chlorine here, and what would the name of that be?
It's still 2, isn't it?
2 chloro, yep. Then what? Cyclo, pent, and amine, right? Because cyclo tells the reader that it's in a ring, the pent tells the reader that it's a 5-membered ring, and the amine means that that's carbon number 1. If you had the chlorine here or here, that'd still be 2 chloro, right? What if you had it right here? Could you have a version where there's a chlorine right there?
Yeah. But it will be a different name.
Right, it'd be a different name. I didn't specify how to break them apart. I just said. So we're just listing all our options. So what would the name of this one be?
3-chloro.
Right, 3-chloro cyclopentanamine. And I misspoke when I said there's only 2 options. There are actually 3 options. Where's the other option? If you had it right here, is that anything new? No. But could you have it where they're both on carbon 1? Yep, that would not break any rules because that carbon's got 1, 2, 3, 4 bonds. That's not going to break any rules. So what would the name of this one be? 1-chloro, right? Cyclopentanamine. In terms of these 3 relationships to each other, what are they? They have a relationship. What are they? Are they the same molecule? Are they unrelated? Or are they structural isomers? They'd be structural isomers, right? They have the same formula, different arrangement. So that was a bonus one. That was not on the handout. I just threw it out for my on-campus students. So if you're watching it online, you just got a bonus. All right, that's where we're going to end for today.